Hello and welcome everyone. I will be jumping onto um, this problem here called the make it increasing. In this problem, you are going to be given an array of n integers, and uh, your final output would be to you have to figure out the minimum possible number of operations in order to perform on the given array in order to make it strictly increasing. Now, the term strictly is important here. Well, what it means is that it should be greater. Any element should be greater than its previous one, not equal. So strictly increasing. And so now, what is the minimum? What is the operations that now the initial given array could be in a different format, but I have to make it strictly increasing by following an operations. I can choose an operation to make it strictly increasing. What is that operations that I am allowed to do? Is I can actually divide any element from the array by 2, and it should be rounded down. So uh, it will be rounded down when I divide it by 2. I can apply to any element any number of times, but that's the thing. I have to minimize it. I have to minimize the number of operations that I want to make, which is divide by 2, rounded down, um, in order to get the strictly increasing array. Hmm. So how do I approach this problem? Now, there could also be a possibility where it's not even possible. The answer could be -1. When could that case be arise? When that case could arise, I would also love to talk about it. Now, let's just take a look at this test case here. Now, what is the best option, or should I call it the best way to think about this problem, is to look at the end points of the array. What do we think would be the best option to traverse the array? If I have to perform the minimum number of operations, um, I would be starting from each and one of the ends. Could be the first end, could be the last end. But what is the efficient way? Uh, well, the efficient way to traverse the array would be from the last one, because at the end of the day, I want a strictly increasing array. So the final value should always be the largest, right? And that's what I'm aiming for. I'm aiming for the largest value. So why not start from the largest? Because that would simplify the traversing and the simplify the thought process. If I uh, if I do talk about this in this way. Now, what am I going to do? I will say, okay, I wouldn't. I would want the operation to be as minimum as possible, and I'm traversing from the back, or should I say, from the end of the array. So, what's the conclusion here? The last element should be the largest yet, right? It should be the largest yet. So, I wouldn't do any operation to the largest value because I want a strictly increasing, and I want to minimize the number of operations. If I do make an operation in the last element, that would simply just increase the number of possibilities, the number of operations. I want my last value to be the maximum as possible, so definitely I would not want to apply the operation here. Rather, I will start from here. So explicitly, I will start my traversing, or should I call it the applying operation, from the last element's previous element, which means here the 7th. Now here, what I would do is simply do what I simply apply the operations until it's less than the following element. That's exactly what I would do, and that will guarantee me the minimum possible operations. How's this working? You can see 7. I will compare 7 with 5. Now I see that, okay, it's greater than, so there's not a possibility up here. I have to apply the operation here. So now if I do apply operations here, I will divide 7 by 2. What's 7 by 2? It's 3. It's rounded down. 7 by 2. It's 3. So let's just apply the operation and let's leave the value. Okay, what's the condition now? 3, is that less than the following, the immediate adjacent rightwards value? Yes, it is. So what would I do? I would simply go back and check it here. You get my point. That's how I would do, and I'll go back. Now what's the condition here? 8. Is it greater than 3? Yes, it is greater than 3, but I want, if in order to get the strictly increasing, I have to make 8 less than 3. How do I do that? I apply the operation again on 8. If I do it, what's going to happen? If I do it divided by 2, 4. Is it greater? Is it less than? No, it's not less than. It's greater. I apply again. What would happen? Now, what's going to happen is it would be 2. So I applied in total 2 operations here and 1 operation here, so that my total number of operations that I've applied so far is 3. Now, I will move. Okay, it's less than. Now I will move here. Well, what's going to happen now? Is it less than? No, it's not less than. Rather, it's equal. So I have to get the strictly increasing one. So I'm not gonna stick with this formation. Definitely, I have to divide it by 2 in order to get strictly increasing one. So divided by 2, we get 1. So the total minimum number of operations is 4. Now, how do I claim that this is the fixed objective minimum number of operations? It's because I am traversing from the rightwards. I'm guaranteeing every time that the value that I have started traversing with is my largest yet. So focusing on this value, I will traverse from the end, and it will guarantee me that I will apply operations if the condition does not match. What if I would have started traversing from here? That would have caused a lot of problems, I think, if I would have started traversing from here, because I have no idea what's the largest value is. In order to get the minimum value, in order to get the minimum number of operations, I would start traversing from the end of the array. Now, there could be some cases where the answer is not available. The answer could be -1. Now, you might wonder, what is the case when the answer is -1? Let me take a look at what if the formation is like that. Let's say I'm given an array and I'm asked to say that, okay, make it strictly increasing. Do we really think that there is a possibility? If I do divided by 2, it's going to be 0 all along. So I have to provide a separate condition, which would say that if at any moment 2 adjacent values are equal to 0, then the answer would be -1. There's no way you could make it strictly increasing. If you divide 0 divided by 2, it's going to give you 0, which eventually is equal to 0. If you keep on continuing this process, it will end up in an infinite loop. It would end up in an infinite loop, so you wouldn't want that. That's a special case we need to check for -1, and that's exactly what I did in the code section. If you just take a look at it, I am taking the values. I am saying, okay, if n is 1, the answer is always 0, as you know that. There are no other elements than that single one. Now, for the rest of the part, I will start traversing from the last element's previous element, as I am considering the last element to be the greatest, to be the largest, and traversing. And this is the optional checking for -1, as I've talked about. And there you go. If unless it's the condition is not fulfilled, I will just until this condition is broken, I will just simply divide it by 2, and increase the number of operations. If at any point I say that, okay, this condition has already been applied, this formation has already been displayed, then I would break simply, because there's no other way. The answer would always be -1 if it's equal to 0. If there's a formation like that, I have actually tracked it with this flag value, which would give me the you know tracking of whether that's -1 or whether there is actually some minimum number of operations that I can apply. So I hope you do understand it. Yeah, and thank you very much.